SAS Programming Challenges in ISS and ISE Studies. Introduction. Now let's consider the integration of 12 studies A, B, C, D, E, F, G, H, I, J, K, L into one ISS and ISE studies. Now while doing the process of integration is nothing but combining all these 12 studies into one ISS and ISE studies that is used for the submission to the USFD or the regulatory authorities, right? So in those scenarios, there are various challenges that are seen, there are various obstructions, there are various situations that arise as to how we need to combine this into 12 studies into one. So let's go through one by one all the various challenges that I have covered in this video. Now the number one is a study design differences. Now the challenge here is some of the studies, it could be parallel, it could be crossover, it could be single arm, another it could be open label designs, and these could differ. So the solution is to metadata driven design harmonization table and pooled population flags. So it's very important whenever you work in ISS and ISE studies. Remember one thing, integration of more than 2 or 3 studies requires proper harmonization, right? If the proper harmonization is not done, your study will fail and it will not give you the required results. So say for example, the scenario here is I have a study A which is into randomized, right, design, whereas in study E it's a single arm design where it's only one treatment. Now this randomization, it could be either parallel or it could be crossover, right, and either it could also be open label. So in some scenarios what you can do here is you can write the hint here is the unique subject ID. You can combine this catax function into study ID and concatenating it with a hyphen and using the subject ID, right? So this is how you can create the unique subject ID. Now you need to ensure that whatever the designs that are present, especially in your 12 studies, in those 12 studies you need to ensure that the pooled efficacy eligibility criteria that needs to be done. So say for example, if I'm having most of the studies are related to 2 treatments, say in parallel and crossover we have 2 treatments, right? In open label also we'll have 2 treatments, whereas in single arm you will have only one single treatment, right? So whenever we do any pooled efficacy analysis, so out of 12 studies if you find that only one study is a single arm, so you can exclude that particular study, because whenever we do the efficacy eligibility we need 2 treatments to do the comparison, right, to get the p value. Then only you will be able to compare and you will be able to test using the chi-square or the Fisher's exact test, which is normally used in the efficacy case of analysis. So it becomes very essential that to bring the harmonization, especially in the study design differences. Now how can you bring the harmonization? When you have the 12 studies, in this video I'm going to consider the 12 studies as an example. It could be less or it could be more than this 12 number, but in this video I'm going to stick to the 12 number. So say for example I'm having this 12 different studies, right? So the very first challenge is you need to understand the study design of each and every study, right? Once you have understood that, and once you have understood that what is the primary objective, especially into the ISS and ISE study, only then you will be able to define this pooled efficacy eligibility, right? So this is one criteria. And the unique subject ID, you can use catask function where you can combine the study ID and subject ID by using the hyphen. This is how it will be give you the unique record. Now how can you give the unique record? Remember one thing, we are having 12 individual studies. Each study will be different. No study will have the same number, right? So 2 studies will not have the same study ID. It will always be a unique number, right? Study ID. So this, when you combine with subject ID, it will anyways, it will give you the unique record in your database. Now, number two is the variable naming and coding inconsistencies. Now, the challenge here is we have the subject ID versus unique subject ID versus subject number. Now, what are these? Now, these are the variable names, especially in the primary key when we consider the subject ID as the variable that is used in most of the data sets to combine. So, this is the primary key source. Now, the primary key, which is the subject ID, needs to be handled very carefully, and the harmonization and consistency needs to be done, so that whenever you combine the records either vertically or horizontally, these 12 integration studies individual data set, so that you need to ensure that each and every record should be unique. It should not be duplicate or it should not overlap, right? So the solution here is you variable map with study specific renaming rules, right? So the harmonization is very essential when we consider the subject ID into unique subject ID. Now this as hint, it could be like you can use the solution as a dynamic renames. We are ampersand variable map study equal to macro. Now this is a specific macro name which you can create yourself using the different study ID. So whenever I'm using a specific study ID, I need to combine that with the subject ID, or say the specific variable. So in study 1, we have subject ID. In another study, we have sub underscore no as a variable name, right? So you can create an automated dynamic macro, which it will automatically combine the study ID and the subject ID, so that your each and every single record is a primary key, right? It's a unique record. Ensure that the variable naming is very essential. Now this is only pertaining to one variable, which is your subject ID. There could be many variables, like say it could be more than 50 variables, or it could be more than 100 variables, where you will need to bring the consistency. Inconsistency will always be there. Now the another challenge would be, like say in some studies, A to ABC, you have the CDISC format, and the remaining studies you will have the non-CDISC standards. Now remember one thing, more than 3 studies are non-CDISC type of variable format. You can imagine yourself how kind of harmonization and consistency that you would like to bring on table, so that when you integrate or when you combine the 12 studies, you get the each unique record should identify the specific study, right, and the database. So it comes very essential whenever you do the variable naming and coding consistencies. It's very essential that you try to create the dynamic macros, because this is the only way to handle multiple studies. Now even when you have created this macro, ensure that someone has developed, another has to validate. Only then things will match, because if somebody, a developer, has written this macro but it has not been validated by any other independent person, especially in your biostatistics or SAS programming team, there could be issues. So a second thought or a second viewpoint is always essential to validate such macros before using in any studies. Number 3 is your lab units and vital signs conversions. Now the challenge here is, like say for example, I have a glucose kind of a test, right? The laboratory test. Now some records are in mg per dl versus millimole per liter in some studies. So in some studies I'm having this unit, and in another studies I'm having this unit. So now again the question comes of harmonization and doing the conversion and the standard unit. So the solution here is to bring the conversion table. Whenever you're working with the lab units and the vital sign conversions, ensure that you have the conversion table in hand, right? So, and you should also know what is the standard unit. So say for example, if I want to convert this mg per dl to millimole per liter, you should know what is the conversion factor. So that conversion factor will come from the table. Now who gives you this conversion table or some factor or all that? Now you are a SAS programmer, right? You can ask to any medical team person, or you can ask to any doctor person who is there as a principal investigator in your study. So that person will help you in bringing those conversion factors, because doctors and the medical team, they are well aware as to how to use this and how to use this conversion factors and converting the units, right? Because being as a SAS programmer and a biostatistician, we need this help from the other team members so that you can understand easily and you can convert it. So scenario is, say I'm having a study F which is millimole per liter and I want to convert it into mg per deciliter. So now here the solution, it could be like, say if analyte is equal to glucose, then the original unit is equal to millimole per liter. Then the new result, that is a numeric original value, it should be this specific value, right, into 18.0182. So you can understand that this is the specific conversion factor or the conversion table. In some scenarios, there could be possibility of multiplying, right? Here we are multiplying the value with the actual conversion factor to get in specific unit, right? So this is one way. In another way, it could be like you might have to divide it, right, or you could have to subtract it. So there are various situations. It's not that always you will need a conversion factor which only multiplies. You maybe have to divide, you may have to minus some kind of values. So this is very essential to have the conversion factor, and the lab units and vital signs, they are very vital and the important factor. Now understand one thing, you are handling the 12 individual studies. Now imagine one thing, in only one study, in few of the records are in this, and in the another records it is this, especially in the one study. So in one of the study you have the mixture of different records in different units. So you can understand and you can visualize and imagine yourself it how it could be a daunting and tedious kind of a job when you work with the lab units and vital signs conversions. One way is to request the vendors who are working at that front to provide the units into the standard unit and convert and give you the final result, right? But if the vendor is not giving you, then the only choice is like either biostatistician and the SAS programmer, they both have to work on it. So you can try and convince the vendors. If they don't do it, it goes into the programmers table, when the programmer have to work on it. So this is piece is a very tedious and a daunting job. So you need to be very careful when you're working with lab units and vital signs, because one single mistake can give the different result when you're combining the 12 studies. Number 4 is your MEDRA and WHO dictionary versions. Now the challenge here is some studies they might use version 22, another studies could use version 25. Now remember one thing, when you have multiple studies, like say you have 12 integration studies, it's not necessary that all those 12 studies have occurred only in the last year. Some studies could have occurred 5 years before, 10 years before, and after 10 years the US FDA and the regulatory authority person, they are asking you to give a combined version, which is the ISS and the ISE study, right? So in those scenarios, what happens, like 10 years before, people used to use, or the team had used version 22. So now latest version has changed. Remember one thing, as and when the time goes, as and when the date goes, your technology and the version, it keeps changing, right? So no matter, even if the study had happened 10 years before, so that study we use version 22, but now we are using version 25. So the solution here is to recode to target MEDRA. So the again challenge here is that whatever you coded in version 22, you might have to do the recoding of each and every record, especially in the adverse events and the concomitant medication. Partially it could be in the medical history. So those kind of situations might arise, right? So scenario, it could be the AE verbatim terms needs to remap with dictionary lookup, right? So you need to combine the AE verbatim from all the 12 individual studies, and you might have to consider recoding it with the help of MEDRA lookup table, right? So whenever the studies you had performed version 22, in some of the studies, say around 6 studies were done on version 22, whereas the 4 studies they were done on version 25, right? So whichever studies they were done on 25 or 22, you might have to recode it. So it's again a tedious and a daunting job, especially for the medra team or the medical team, to recode everything and to ensure that while doing the recoding, whatever the terms, verbatim terms which were present in 22, it should be present in 25, and those terms which are not present in 25 but it is present in 22, so in those scenarios again there's a loophole, right? The latest verbatim numbers or the latest verbatim adverse event terms, they are not able to seen in version 25, whereas they are present in version 22. So in these scenarios, you might come, and it will come when you are working with such large and huge database. So in those scenarios, you can seek the approval of the sponsor, or you can seek the approval of the ethics committee as to how to deal with such kind of version numbers and how to ensure that the coding is done properly. Now, number 5 is your visit schedule and mapping. Now, the challenge here is visit labels differ. Now, in some studies, it could be week 4, whereas in some studies, it could be day 28. So, we have here 12 individual studies. Now, we are combining into one ISS and ISE study. So, the solution here is to visit mapping table with day windows, right? So whatever the differences are there in, especially in the visit labels, the very first thing is to sit back with the protocol and ensure that what is going to be present in the one ISS and ISE study. Are we going to present the data in weeks or in days? So whatever that is mentioned in the protocol or in the statistical analysis plan of the ISS and ISE study, you need to follow that. But practically, the solution is to do the visit mapping. So say for example, I have a scenario which is day 14, it turns to week 2. So you can use proc format or dataset driven ampersand assign underscore visit. So you can use this, again you can create this macro. Now this macro is something kind of a name which is given. You can create your own macro. So wherever there is week 4, we assign as a specific day, a day 4 or day 10 or day 28 refers to some week, right? So in those scenarios, you can use this macro as a dynamic one, so that your minimum time is spent in coding, and the more focus should be on getting the correct results and the validation or redoing or the traceability of data. Now, number 6 is the duplicate subject IDs. Now, the challenge here, it could be subject is 001 in multiple studies. Now, here we are having 12 individual studies. So, it could be possible that, say, in more than 2 to 3 studies, subject 001 is repeating. So in study A, I am having 001, whereas in study G, I am having again as 001. But the study number is different, the study ID is different, but the subject number is same, right? So what is the solution to handle this challenge? So that you can use study ID into subject, which is the composite key. So scenario, it could be, say I'm having study A which is 001 and study E is having also as 002. So in those scenario, you can use this catas function by creating this new variable unique subject ID. You can concatenate with study ID, and you can use strip function to subject ID. So study ID and the subject ID, they are concatenated with this function by using the hyphen. Very simple to understand, right? The strip function is used to ensure that whatever there are leading blanks or leading blanks, like say in starting subject ID, there could be some blank values, or after subject ID, there could be blank values. Remember one thing, if you are handling those studies which were conducted 10 years before, 5 years before, whatever format or the consistency that you are using right now in the database system that could not be present in the 10 years before, right? Something or the other could have been changed. So just to avoid the leading and the trailing blanks, which is quite possible to have in front of this subject id variable values, you can use the strip function. Similarly, you can also use the strip function in front of study id also, so that whatever the leading and the trailing blanks which are there, it can be removed easily by this strip function, right? So it's very easy to use. So you can handle this duplicate subject ids if you are having in multiple studies by this function. Number 7, baseline definition variability. Now the challenge here, it could be you will have baseline is equal to day -1 versus day 1 pre-dose, right? So how to overcome this challenge when you have different baseline definitions variability in different 12 individual studies? So the solution again here is only to harmonize to get the pooled baseline definition, which is nothing but the last non-missing pre-dose value, right? So before consuming the drug, whichever is your was your last non-missing value, that is my baseline, right? So the scenario, it could be you need to reconcile different baselines so that the common baseline definition is used in ISS and ISE study. So you can use maximum date, where ADT is nothing but your date of your specific visit, and then which is should be strictly less than the treatment start date. So this is nothing but the date of start of treatment. When is the treatment that you took, on which date, right? So the treatment started, which should be greater than your date. So you can use this kind of baseline definition variability so that you can come up to the harmonized values. Number 8, missing data handling. Now the challenge here, it would be the missing data, especially in some of the studies they are presented as 999, whereas in some studies it is used as NA, which is not applicable, and in some studies it is used as blanks across studies. So in the 12 individual studies, the missing data was handled differently, and it was presented also differently, because those studies were conducted 5 years before, 10 years before. So you may not know like who was the primary investigator or principal investigator, or who was the database manager, because that person might have even resigned, may not be present, or he may have died. So you do not know which team had worked on that specific studies, which was 5 years before, 10 years before. So it becomes very difficult to get the traceability, right? So in those scenarios, even if it is 999 values or any or blanks, you need to ensure that all the missing data are handled and presented in a single value. So the solution here is to normalize this to missing for the numeric values, or you can present as blank for the character values, right? So you can apply the pooled implementation rules. Now again the question is for harmonizing pooled implementation rules. So see this scenario, in study H I am having 999, so you can replace this 999 to dot value, which is missing, especially in the numeric. Now if the original lab value is in 999 and NA, then lab value it should be missing. So you can understand this is only specific to one lab test or of one record. There could be so many variables, and there could be so many values and the records which will be presented in the missing data, this 999 and NA. Now you have to replace it to missing and character in your ISS and ISS study. So in all the 12 individual studies, you need to first identify how this was presented, right? So you need to read and go back to the statistical analysis plan of each and every 12 studies, that there will be one section called as handling missing data in the statistical analysis plan. So how did they handle the missing data? It will be presented in the statistical analysis plan for each and every 12 studies. Well, if it is presented and if it is informed, then it's no issue, you can just follow that. But in case if that person whosoever had written the statistical analysis plan has forgotten to add that section as to how to handle the missing data, then it's going to be the daunting and a tedious job for you to ensure that you are converting the correct this non-missing values to your missing, right? So because what happens is in some situations you should ensure that the real values or the actual efficacy values should not be replaced. If you do that, then again it's going to be a challenge, like, to get the correct results. So it becomes very strict rules needs to be followed, and your precision and the attention is very much needed when you are converting all this missing data, and you're converting in when you're using this condition statements, right? Because you are keeping this some values you are replacing with missing. And as you know, whenever you do and perform any summary statistics or counts and percentages in missing, you do not get any actual results and values, right? So if you have done some blunder in converting this missing data and handling, then those values you have not considered in the analysis, and it will not be presented in the tables and listings, right? So ensure that the correct blank values and the correct missing data is converted into specific numeric or the missing for the numeric and the character values appropriately. If it is possible, you can check your study records 2 to 3 times to ensure that the consistency is maintained. Number 9, population flag differences. Now the challenge here is ITT, MITT, which is modified intent to treat population, then safety population rules vary, right? So say in some studies they have used ITT, in some studies they have used population safety, and in some studies they have used MITT, they have not used ITT and safety. So in those scenarios again, like, you need to ensure that the solution is to get the harmonized pool definitions. So the pool definition, it should be very precisely mentioned in your ISS and ISE statistical analysis plan. So those population definitions, when you are mentioned, considering all the individual definitions that were present in the 12 individual studies, you can come up with a better one, and you can use this ITT is equal to nothing but all randomized plus greater than or equal to 1 dose, which means all those patients who were randomized and who took at least 1 dose of treatment, right? All those subjects and patients will be considered under ITT population flag. So in those scenarios, you can create the ADSL underscore pop flags data set. In some studies we use as the pop data set, like, just to ensure that we create an Excel sheet, and when you convert all these subject numbers. Now here we are considering the 12 individual studies, so you can imagine the records could go more than 1000 to 2000, or it could even go to 5000 kind of records. So it could be very difficult to maintain in the Excel sheet, so it's always better to handle in the SAS data set. So in those scenarios, you can create this specific data set, and you can create a specific macro as per your comfort zone, as to, like, how you can maintain the pooled definitions. Now the number 10 is the exposure calculations. Now the challenge here is dosing is captured differently, right? In some studies the dosing was captured in another unit, whereas in some studies the dose was captured in another unit, right? So whereas in some studies there were the start dates but there were no stop date, or in some studies they had start date and stop date, in some studies they had only stop date but they did not had start date, right? So those kind of situations it might arise. So in those situations the solution is only to get the canonical exposure data set with total dose and duration. So say for example scenario here, the study L has only start and stop dates, right? So you can use prog SQL to sum the dose and derive the treatment end, like whatever is the treatment end date. So those kind of calculations which were there, especially done in the individual studies, the dose calculation, which is the total dose calculation, then the duration and the dates and the stop dates. So all those things needs to be ensured that the consistency is maintained. If the consistency is not there in the 12 individual studies, so the first thing is you need to go through each and every study. You need to understand how the exposure was calculated. Now once you have understood that how the dosing was captured in each and every 12 studies, then you need to sit back with the pulled definition as to how I'm going to calculate the exposure or the dose in the ISS and ISE study. So once you have these two things, then you can come up with some formula or some macro as to how you are going to do it in the programmatically, right? So all those conversions and it will be there. Again, when you are working with the exposure, lab results and the vital signs, it's always a tedious and a daunting job. So you need to be very careful and you need to pay attention a lot when you work with ISS and ISE studies. Number 11 is time to event consistency. Now the challenge here is OS is by overall survival, PFS is the progression free survival. Definitions differ. Now definitions across all 12 individual studies somewhat is same but little bit is different, right? So again the solution is to get the harmonized censoring in the event rules. So say 0 and 1, like the definition of 0 and 1, they were swapped, like in some scenario, because some programmer did a blunder 5 years before, so now you need to rectify. So you don't know who the team was earlier, so you have a new team which does not know anything what has happened earlier. So it becomes very essential, like to do the harmonization. So the scenario here is your central and the investigator progression dates, and you can use PFS time is equal to event date minus randomized date. So these kind of situations you'll come across in the time to event consistency. The censoring also, the definition, time to event and time to not event, how we are censoring to 0 and 1. So those values, it needs to be harmonized, and if it is not done properly in some of the studies, then you might need to use the conversion or the um, conditional statements you might need to use, so that you can reflect in your ISS and ISE studies. Now number 12 is your endpoint definition variability. Now the challenge here is you will have continuous versus binary responder endpoints. Now endpoints is nothing but your primary, secondary, exploratory kind of endpoints, right? So say in some studies they had used the continuous values. In some studies they had converted those continuous values to some binary, like say yes, no, 0, 1, or some kind of typical label that they had given. So in those scenarios, the solution is only to convert wherever possible, and you can use the meta-analysis. So say scenario, it could be the percentage change was used in one of the study, whereas in most of the study you have the binary responder endpoints. So it's very comfortable to change one study rather than changing all 11 studies, right? So you can change that one study which is there in percentage change, you can convert it into the responder factor. Now using the threshold is nothing but below this value it will fall in this category, above this value it will fall in another category, right, which is A and B. So in those kind of situations, you can use the threshold value. Responder is nothing but, like say, either the result was yes or no, or either the category value was A or B. So when you use the threshold value, if the percentage change is less than this number, less than this threshold number, it is yes, or if it is greater than this number threshold value, then it is presented in no. Same, it will be presented in A and B respectively. I hope you got my point. So you can use prog mixed for continuous, and you can use GLMI mix for the binary responder endpoint. So these kind of procedure changes you will always be needed, because it's not essential that the endpoints values, especially in the efficacy situations or the efficacy parameters, they will be same. In it could be different, so you need to go through even all these endpoints and all those. It's a very tedious and a daunting job. So you need to be very careful when you're working with the endpoints definition. So this is the very important factor in the slide where this affects the actual efficacy results. So you need to be very, very careful while performing this. So say number 13 is your data cutoff dates. Now the challenge here, it could be there could be different database log cutoff dates across studies. So say in some studies there is some cutoff were used, in some another studies it was not used, but in rest of the studies some different cutoff dates were used. So the solution here is again to use a unified pooled cutoff, right? So you can use specific date for all those studies, that I want to extract only those data which is less than or equal to this specific date, right? So this is my pooled kind of cutoff, right, which I have designed. So you need to also come up with this cutoff. Now this cutoff date also, who can give you? The number one is your primary investigator, who will know that I am conducting this ISS and ISE study only for those database which have occurred to this specific date. So the number one is your primary investigator. If that person also is not able to give you the answer, then you can go back to the sponsor, because sponsor is very much clear that he wants the database up to only this much date, and only database till that much date only we need to analyze. So you can use this where function ADT, which is less than equal to pooled cutoff. So this pooled cutoff is nothing but this specific value which is there. So you can use ampersand and you can convert it into your date while using the character values, right? Number 14 is a randomization and strata differences. Now the challenge here is we'll have the different stage stratification. Now stratification in very simple words is nothing but groups. In one study it will be different, the group is different, and the another study the group is different. So how it could be different? In study A it is region, whereas in study E it is stage. So the strata is different, or the group is different, because it is analyzed also differently in the 12 individual studies. But now we are not to focus into the one ISS and ISE study. So what is it that you can do? So you can need to harmonize it to one strata map. So only either we will use region as a factor in the ISS and ISE study, or we will use stage depending on the availability of data. Now again remember one thing, it's not necessary that the strata mapping you will have the same strata across all studies. In some studies the strata will be completely absent, you will not have that strata. So again you need to go back to your medical team or a doctor or a principal investigator or to the sponsor to ensure that, so that they can help you. This ISS and ISE study, we are going to use the strata mapping, or we are going to classify the table listings and figures by using the strata classification. So in this study we are not having the strata. So how do we convert, or what strata needs to be added in that specific study, so that how we can convert into the records? So you can use class statement as strata or a group in mixed and the Cox models. Now this is the programmatically, but technically and practically you need to understand the strata differences. So for understanding this you need to go back to your mock shells of each and every individual 12 studies, and to see in where study which strata was used. Similarly you can come up with the harmonized for the one ISS and ISS study. Now again this is a very daunting and a tedious kind of job to go through each and every study. First of all you need to understand each and every study. It may not be possible that in just once you have read that study you will be able to get the feeling of the entire study. No, you might have to go through the specific study, twice or thrice. Now imagine only one study you have to go twice and thrice so that you get the proper understanding. So there are another 11 studies. So first you need to understand each and every study. You have to get the proper thought process, your planning process, your strategy needs to be right, your harmonization, it needs to be right, your pooled definition, pooled strata, pooled formula, everything has to be pooled. So that's how things will work out and give you the good results. Now, number 15 is the therapeutic area differences. Now, the challenge here is in some studies oncology was used, whereas in some studies metabolic studies were used, right? So, again, the solution is to get the pooled analysis. Now, it could be rare to rare cases where the ISS and ISE study, they are trying to combine different therapeutic area differences, right? So, in study A, it could be oncology, in study A, it could be metabolic. So you need to combine with these pooled analysis, and you need to stratify all these analysis by therapeutic area, right? No matter, even if like say for example, I'll give you the demographic. Now the demographic of the cancer patient and the demographic of the diabetes patient, which is into the metabolic, right? So those kind of therapeutic areas are completely different. Oncology is different, cancer patients, and metabolic is related to diabetes disease. So when I'm trying to present the demographic table, I will have to stratify into the pooled analysis by therapeutic area. So I will combine all the 12 individual studies into one ISS and ISE database, and I will use the pooled analysis, and I will stratify that specific demographic table into two different therapeutic areas, one for oncology and one for metabolic, which is cancer and the diabetes respectively. So whenever you are stratifying this by therapeutic area in the demographic table, you need to understand one thing is the values, the total value should match. That is the number of subjects in oncology and the number of subjects in the metabolic. Those studies should match, right? So that is one way of doing the validation. Right. And like say, for example, you might have another studies which has used some another therapeutic area. So even that can be presented. It depends on what therapeutic area is same across all 12 individual studies, or it's a different. So this is going to be a first question, whereas the therapeutic area for those 12 individual studies, which I'm going to combine into one ISS and ISC study, are they same or they are different, especially the therapeutic area? So this should be a first question. Then only your life will become easy. If the therapeutic area is same across all 12 individual studies, your life is going to be easy. If it is not, then it's going to be a bit challenge, because the efficacy variables, efficacy endpoints, efficacy values is very much far more different for oncology and the diabetes patient. Look at the vast differences of the diseases. Oncology is cancer related, where you have stage 1, stage 2, stage 3, stage 4. Diabetes, it does not have any stages, right? It will have type 1 and type 2 kind of diseases. So it's very essential, you need to, even the analysis is also different. When you come back to oncology, you will have survival analysis, then there's OS and PFS, progression free survival, whereas in metabolic it will be different kind of analysis that will be used. So all these factors and the challenges you will always come across whenever you're working in ISS and ISC studies. Okay, number 16, AE reporting windows. Now the challenge here is on treatment versus on treatment plus 30 days. Now remember one thing, the adverse event definition is considered that whatever the events that occurred on treatment, like after consuming the treatment, whichever the events that happened related to headache, fatigue, or nausea or vomiting, so in those kind of events that occurred after consuming the treatment, those events are considered as your adverse event. Now in some studies it is considered as on treatment plus 30 days, whatever is your period. So the window period is different. So the solution here is to harmonize the AE window flags. So say study A, I am having one specific definition, And in study E, I'm having another definition, which is on treatment plus 30 days. Whereas in this specific study, I'm having only on treatment. Those 30 days window period is not there. So what is the solution to combine all these 12 individual studies into one ISS and ISE study? So you need to use a consistent and valid AE window flag definition. So if the definition of adverse event, if it needs to be changed, or if it needs to be redesigned or refined in the ISS and ISE study as compared to your 12 individual studies, then you might have to even do that. And also when you are combining the adverse event, say let me give an example. In 12 individual studies, different adverse events definition was used, and they were converted, or they were classified as adverse events, right? Now you have combined all those 12 individual study database of adverse event into one data set, right? So now you have used the new consistent and valid AE window flag definition. So what you need to do is you have to redo the analysis, and you have to recalculate the events whether they fall under the adverse event by using the new definition of ISS and ISE study, right? I hope this is clear. Okay, number 17 is QC and reconciliation. Now the challenge here is ADSL versus DM discrepancies. Now what happens is these two data sets, there might be some discrepancies. So the solution here is to use proc compare or the discrepancy log. Log, you can use your SAS log or some other log which that you are using in specific software. So say the scenario here is I'm study A, I'm having ADSL age, whereas in study A, I'm having DM dot age. Now remember one thing, I'm talking about only one study. I'm having two different data sets and the same variable, right? So the age is different. Here the age is 11, whereas here the age is 12, which is not possible. So the data should be consistent in raw, SDTM and ADAM data sets, right? Now this is an SDTM data set, and this is the ADAM. Now ADAM is derived based on SDTM, and SDTM is derived based on raw. So whatever the value of age is present in raw, same should be reflected in SDTM and same should be reflected in ADAM. So that is called as a reconciling the specific values in all the three sections, which is raw, SDTM and ADAM. So it's very essential that whenever you're doing the QC, the discrepancies needs to be resolved, so that then only your things will match. Now remember one thing, you're going to do this for each and every 12 individual studies, or you could at the end, after combining all those 12 studies into one, you can later do that, or you can individually do that. It depends on yours. The choice is yours. Now, number 18 is performance with large pool data. Now, the challenge here is I might have 2 million rows, right? So, the solution here is to use summary data sets. You can use keep equal to, or keep only this specific rows or this specific parameter values, or you can even use indexes while doing the program. So, while handling the large pool data, you need to be very careful to summarize and use the keep function. Number 19 is your TLF consistency, which is table listings and figures. Now the challenge here is study versus pool denominators. Now the table listings and consistency, it needs to be there across all 12 individual studies. If it is not there, like say for example the denominator, the percentage was calculated by using a different denominator in study A, whereas in study D, some other denominator was used while calculating the percentages, right? So whenever you're converting or bringing all this data into ISS and ISE study, you might need to come up across with the pool denominators, like a common denominator which is used across all 12 studies, and then you are going to convert it, or you are going to keep it in the ISS and ISE study. So the solution here is to use the parameterized table listings and figures macros. You can use macros nested macros also you can use, so that you can bring up to only one definition and your life becomes easy for calculating your percentages or calculating any calculation that you have done wherever you are using the denominators. Number 20 is traceability and audit trail. Now, the challenge here is the regulator needs traceability. Now, what is traceability? Traceability is nothing but whatever data that is present in raw, same should be present in SDTM. The format structure is different. Remember one thing, but the data values should be same from raw to SDTM and from SDTM to ADAM. Now, if you are an experienced SAS programmer and a biostatistician watching this video, I hope you understand the database structure of raw. In any clinical trial study that you're working in any company, the structure is different. The SDTM data structure is different and the ADAM structure is different, right? But the values, what is present in that structure, especially in the raw, SDTM and ADAM, it should be same, so that if I want to go back from ADAM to SDTM and SDTM to raw, I'm going back and checking the values whether the values that is present in ADAM, the same should reflect in raw and the same should reflect in SDTM, right? So the solution here is to manifest plus source that you are using in pooled and pooled into the output mapping. So whatever you are using in the 12 individual studies, right? So no matter the format structure of 12 individual studies, it could be different, right? That is, the source is different. 5 years before, 10 years before that study was conducted. So, but obviously the format design, the format structure is different, but you are combining into the pooled, like you're combining into one structure, so that you can do the correct mapping, and whatever you're doing is the mapping. You are mapping from study 1 to study 2, study 2 to study 3. So all those 12 individual studies, they need to be mapped into the definition of ISS and ISE that you have mentioned in the statistical analysis plan. So that what you're mapping, it needs to be done. So that is my traceability. Now here there are certain templates and tools you can use or you can develop or you can design in your SAS programs. You can use harmonizing variables, you can assigning visits, then computing baseline, aggregate a definition window flags. So here are the variable underscore map using the variable harmonization, visit map you can use at visit alignment, lab unit map, lab conversions, CTC AE map, grading harmonization, pop flag underscore rules, which is population flag. So you can use this tables or you can use this macros, so that when you write this macro or when you call this macros in individual 12 studies, you get the harmonized values as is the new result, so that it becomes very easy to integrate into your ISS and ISS study. You can either integrate horizontally, vertically, whichever is your strategy or the way of combining the data, right? So these are the templates or shortcuts that you can use. But even if you are using these macros and tables, ensure that whosoever is the developer, you need to have an independent validator, so that whatever things which were not taken care by the developer, independently it has been validated, so that the quality of the values and the quality of data is maintained while doing the harmonization process, right? Now the checklist for ISS and IC pooled delivery. So the number one is metadata and harmonization rules documented. Now when we work in a clinical trial study, the thumb rule is whatever is conducted, you need to be document, and whatever that is not conducted, that also needs to be documented. So the documentation in clinical trial is very essential. So whenever you are doing any harmonization, like say you have the harmonization rule in in 4 studies it is different, whereas in the remaining 8 studies the harmonization rule is different. So we need to document it that in this specific study A, I'm going to use this rule. In this specific study D, I'm going to use this specific rule, so that I get a common values, or I get a finished product in the ISS and ISE study. So the documentation is very essential when you're writing and combining these 12 studies. It's not going to be easy because it's a huge pool data that you're going to work on. Now, unique subject ID, uniqueness enforced. Now, this is very simple. Like unique subject ID is like, you can just combine the study ID and the subject ID, so that each and every record is unique when you are combining into your ISS and ISE study. Now, the units and visit, it needs to be standardized. It could be either your labs, your vital signs, or any kind of efficacy parameters, or the visits, they needs to be standardized. So those standardization you can mention in your ISS and ISE statistical analysis plan, and the same it needs to be converted. Now the meta version harmonization, right? So the version, it needs to be harmonized. No matter the different meta versions were used in different 12 individual studies, but when you're working in the ISS study, ensure that the same or the one version, it needs to be used in ISS and ISE study. The baselines consistently defined. So the baseline, it needs to be defined as a pooled in ISS and IC slab, and then you can convert accordingly your database from 12 individual studies. Then your populations are flagged as per the statistical analysis plan. Now, which statistical analysis plan? As per your ISS and ISE statistical analysis plan. Now remember one thing, when you have the database of each and every 12 individual studies, you will also receive the 12 individual statistical analysis plan. Now all these statistical analysis plan, you need to read what all populations that were used, and the same, it needs to be combined or integrated into your one statistical analysis plan, which is for ISS and ISE study. Now the exposure metrics derived. So whatever the calculations that was done in the exposure, or the dose calculation, duration, or any kind of factor, so that needs to be harmonized. Then the endpoints, it could be either primary, secondary, exploratory, or any meta-analysis that was done, so that needs to be harmonized. The cutoff date applied. So the cutoff date has to be same, or we need data only up to this specific date, not after that, right? So all those cutoff dates can be applied. Now the QC checks needs to be completed audit trail. Now whenever there is a QC department involved, ensure that whatever quality check that was done, or each and every audit trail needs to be presented. Now the table listings and figures, they were generated with correct denominators, right? So the denominators, it could be different. Like say in study A, the denominator was used as safety, whereas in study B, the denominator was used as per the treatment group, and third study, the denominator was used as ITT population. So the denominator is different. So what you need to do is, you can need to again come up with the pooled definition of denominator that will be consistently used in your ISS and ISE study. So those, it needs to be done. Another is a traceability confirmed. That means individual studies to pool study, and this pool study is nothing but your ISS and ISE study. So these are my 12 individual studies, right? So whatever data that is present in this way or that way, everything, it needs to be harmonized and combined and consistently in such a way that it is transferred as a pooled study, which is nothing but called as your ISS and ISE study, because this ISS and ISE study is nothing but the integration or the combination of 12 individual studies. So however that data is present, either this way or that way, everything should be present in pooled, no matter what. So that is the thumb rule whenever you are working with the ISS and ISE study. As per my experience, I have worked in most of the companies for the ISS and ISE study. It's not a very easy job, so I'm just sharing my experience. It was quite challenging in this terms of, like, very tedious and daunting, because you have to check each and every minute details. if single minute details if you have missed or if you have not considered, just imagine, your entire analysis of the result might go wrong. So you need, your attention is very much needed, and you need to ensure that no mistake should be happened, so that you have to handle all these studies very carefully. So that is what is my takeaway for this video. Please like, share, and subscribe. Leave a feedback comment mentioning any topic that you want me to make a video. Looking forward for a positive response. Thanks for watching. Please like, share, and subscribe. Leave a feedback comment. Many thanks for your support and having great connection.